works fine, so I'm doing that. And
So, so you can do it on the mill. You don't need to use the lathe to make those little posts.
yeah, no, I didn't think, because I didn't know that I could, with it being that small, like how are you going to hold that down to the mill? But I'm basically super gluing like a sheet of copper down, and then cutting it.
Just cutting around
and then
it.
you pull it off. And
Oh
it
yeah.
pops off.
Yeah. Where'd you get the lathe from?
I found that in Ohio on Craigslist.
All right. Well, walk us through this from start. I guess
Yeah.
macro and take us down micro.
Okay. I don't know. I mean, so basically, like it started with these, which are optical slides. They have screws that are. So there's a motor in here.
It's the X and Y plane, basically.
Yeah, it's the X and Y plane. So the motors in here move, and these I got these because the lead screw, so the screw that moves it back and forth, per rotation it only moves 0.5 millimeter, and so most like a bigger CNC machine of one rotation will move it like 5 millimeters, and this, because it's so small, I can end up using like much crappier motors and drivers and everything else for it, because you're getting the mechanical accuracy built into it. And then this is the Z-axis, so this has a motor up here, and then for that one, because I'm not doing as much movement up and down, it's essentially just engraving, so that has much the ball screw in there is much coarser, so that's a 2.5 millimeter ball screw, so it moves up and down 2.5 millimeters per rotation.
Yeah, okay, because it's the up and down isn't as much of a thing for you.
Yeah, and so this is a spindle, so that is, it's a German.
This is the German thing.
Yeah, German made.
30?
It'll go 100,000.
100,000 RPM.
100,000 RPM, yeah. So that gets hot, so the cooling, they make a amount that's water cooled, but I didn't want to spend that money on it, and so I just built my own. So these tubes just go through and transfer the heat from there back through. There's a little radiator and fan here. It's just like a car radiator, and then there's a pump here that just transfers that. And then in here is all the brains of that. So there's a controller for all the servo motors.
And what is the computer?
It's based around, it's like a Arduino based things like
So you just hook up your computer to it and the software, and you tell it what to do?
Yeah, essentially. So this is just a crappy laptop. So this is the brains, essentially. This runs everything, and then the controller there just takes the signal from here. This is the controller on it, and so with that, it's just like so you can jog it around. So this will just do like this would be running a program on a dial here, and then it's got it runs on coolant.
Yeah. Oh yeah.
So that just comes through.
So you got a pump here that's doing all that.
Yeah. So the pump down that ice cream container.
What program is it doing now? Doing
So
letters or
that
something?
is making
What's the size of the bit?
So that's a 0.5 millimeter. So that's pretty big compared to most of the stuff I
The
do.
tip is a 0.5 millimeter.
Yeah, the tip's a 0.5 millimeter. The shank is 3 millimeter. So that's relatively big compared to some of them. 0.3 millimeter. So it's just like it's not even there.
Yeah.
It's like a hair sort of thing.
Yeah.
So that's been interesting, because these, like, they're so goddamn fragile that if you fuck anything up, they fuck up. And so finding how fast I can move has been interesting, because if you go too fast, it breaks, and if you go too slow, it just burns it out. Yeah, and so that's the one thing I've been finding, like figuring that out has been interesting. Brass is like, that's what I'm making the dials out of, but then for the hands, it's stainless, which is like really definitely one of the trickier things to machine. Yeah, so that has been a lot more interesting. Just
That's
because
stainless.
Yeah.
How thin is that?
So that's 0.008 of an inch. So that is for the hour and the minute hand, and then I have a 0.006 for the second hand, because it's a little bit lighter duty. So machining this has been more interesting, and so I've just been going through bits basically, and it's like 35, 40, 50 bucks a pop. And you can't even tell
an
when
hour of bouncing.
Oh, I know, and you can't even tell when they break. It's just like, oh, it's not making a cut anymore. What happened? Yeah.
No.
So I'd like to get like a little microscope, like a little digital camera, so I can kind of see what it's doing. Yeah, the video get closer, right? Yeah, totally. I mean, that's also the bigger tip with a smaller one. Maybe it'd be cool to like be able to video it. I'd like to do like slow mo of it cutting.
So these are the ones you've made so far.
Yeah, so these are the seconds, and these are kind of, they're all, some of them are bummed obviously. That one didn't come out so well. But yeah, I'm working on.
And that's the one that you.
So yeah, so that's the first one I cut. So that was like the first version, and I'm not crazy about it. The hour markers are too small. Yeah, so this is another one. Yeah, it's just been like tons of basically fucking around and getting the process down. This is half a millimeter in diameter, and then it's got a center hole of 1/4 of a millimeter.